It's a YouTube video. Oh gosh, hello friends. Hi, I'm doing better today. These are all good. Okay, what's that? That is stuff. So yeah, while I'm getting my other stuffs together, I cannot count everyone who owes me things. Please go through the grade book. And you might even be this person who's like, I don't know him anything. I'm not gonna look at the grade book, look at the fucking grade book. Because that's what I think is happening in a few spots. People are like, I don't know him anything, everything's fine. Just go look. If it's a 5, you need to do corrections. You don't need to do those proctored, you just need to give me corrections on Wednesday. If it's a 1 or a 0, well, 0 means you didn't take it. 1 means you need to retake it. And you need to set that up with me at least a day in advance. Here, I got some stuff to hand back. Let's just do this.
Same with the 4, right? You need to retake that.
4?
4.
You got a 4?
I think so. No. I guess I'm asleep.
I don't know about that, but that sounds like a retake, but it should be. Yeah, I don't know. I'll have to look.
I'll recheck.
Please check. Please check. This stuff is all, and also check that I recorded anything you turned in that should be recorded. Like if you put corrections, because Alexander had like something I forgot to record it, and so or I just didn't record it is what it came down to. So make sure everything's recorded, and if it's not, let's deal with that, please.
Actually, Dr. T.
Yeah.
All of mine are correction sets 1. I think I'll just
Awesome.
to take that again. The 1, my 1 or
You don't want to take it again? You're saying?
not really.
Okay. Okay.
All the rest of them are fine.
Yeah, I mean, like I would say letting go of 1 is fine.
Yeah.
You know.
Can we retake it after the break, or would you rather just cut it off?
I would kind of like.
worried about them.
I'm not gonna say definitely not, but I kind of just don't want this becoming
Yeah, that's fair.
the end. I don't want to like day before finals, week's end. Somebody's like, I need to take them all.
I would do this. I'm like, honestly.
That's how I used to be. If you got freshman year me, you would have gotten.
Also, look at me. If no one co-signs by like.
I kind of knew you before. I knew you for a few years, right? Just one?
That we only known each other since last year.
Is that it?
Yeah.
Huh.
I transferred in.
Yeah.
So.
Oh, well, I guess, yeah.
Like one in by like.
I'll trust you.
Like I could just have my parents co-sign.
All right. So, what's on your agenda? What are you gonna do? Check shit. Go look at the freaking grade book, and you're gonna make sure everything's recorded right, and you're gonna make sure that. So, I am not coming in Thursday or Friday this week. I'm just not coming in Thursday or Friday this week. I'm done. I'm just staying home after that. Christian and I are gonna go to something on Thursday night, a school event, a grade school event.
Oh, that's cool.
But that means you could, yeah, it's math
Oh,
club.
that's it.
You could take them on Thursday or Friday if you want. I can rig that up. I can set that up, but I need to know on Wednesday. Yes, sir, Zar.
Real quick, on skill check A, is that the one you said where we don't have to do because you said it online?
Yeah, yes, one of them you just said, I think it even says just set them up, right?
It says right in the representing the argument.
Yeah, just the inner, yeah, that's it. You do not have to work them. You cannot work them. They're impossible. So if you work them, you've done some bad math, obviously. Yeah, you've done some foulness. Okay, is there any questions?
Done some evil on
Evil math. Is there any questions on any of this stuff? We're all good? Cool. All right, let's roll. We're gonna talk today about tangent planes and differentials. Multicolors are gonna be good. Multi-hues. Let's get all 4 colors here. All right, and then Wednesday is skill check day. And I'll send you out an exact list. There are web work assignments up that should get you through everything you need. might have to put a 1 on differentials. I'll check that out. But I'll email you all by tomorrow morning and let you know for sure what's up. So we've got this problem, this equation, this relationship between zx and y, but we might also have a slightly different one, and we'll get to this today. I might also have an equation of this form. So this is explicit, and I was just talking to my friend Alexander about this the other day. This is an explicit representation. Explicit meaning you give me x and y, z gets cranked out by this formula. Implicit means the relationship might be more tangled here. So this might be something like x squared plus y squared plus z squared equals 1. That's an implicit relationship among the variables. And so this f of x, y, if I wrote this, here f of x, y, z is actually, notice how there's a 0 there? There could be a constant there, but we're gonna set the protocol that we keep zeros there. So notice that if I make this like that, now I've got an explicit relationship.
So is it, I'm just like trying to.
Yeah, no, yeah, please ask whatever's.
So is it just it being equal to 0 that makes it explicit?
No, it's that I don't have, so if I gave you x and y here, so
Yeah.
like I said, x is 1, y is 2, you'd come in here and you'd plug those in, and you'd say, well, okay, that's 1 squared plus 2 squared plus z squared minus 1 equals 0, or equals 1, wouldn't matter. I still have to kind of do some work to find z,
Yeah.
so I have to take the square root, the plus minus square root. Does that make sense?
And that's what makes it implicit?
That's what makes it implicit.
Just unknowns?
Yes. Well, and implicit means, explicit just means there's a direct formula for this output variable.
Okay.
So like if I said, if I solved for z here, let's go ahead and talk about this because this is worth having a conversation about. If I moved everything to the right, I would make that plus 1. Let's get these guys back here. Minus x squared minus y squared. Still, I don't have a direct formula for z. Here's one thing I'd like to just point out. When you're the one taking square roots, you definitely need to put a plus or minus in front, right? This is classic. People take square roots and just do that. Like not just one person, lots of people in here, multiple people in here I've seen do that. So when you take the square root, you don't know if it came from the plus branch or the minus branch. And so here, Daniel, there's kind of another difference here. This may or may not define a function of z in terms of f and x, y, because here I've got 2 outputs for 1 input. And that's, functions give me exactly 1 output for 1 input.
Oh, okay.
So it could, this actually could be multi-valued. Does that make sense?
Yeah.
All right, let me give you an even worse one. What if this were sine of z? Right? Then there's no really happy way to talk about what z is without talking about arc sine. And then there's just all sorts of problems with arc sine too. I mean, everybody has a problem with arc sine. It's just beastly, right? Does that kind of help
I think so.
explain a little bit? Yeah. Is there any other questions on just setup? That's a great questions. Okay, cool. So we'll get to this in a minute. The reason something like this would be helpful is because if I were to sketch out all the x, y's, and z's that satisfied this, can anybody kind of guess what that might be in 3D space? Let me do the shape first. What? Sphere. That's a circle in 2D. Had that z squared. That is a sphere. This is actually a unit sphere in 3D space. Yep, and then that would be 1, 1, 1. So if you sketch those all out, and we can talk about that some other point, but it's nice to be able to talk about a sphere without having to talk about, see right now it's not a function of x and y, because for every particular input you've got a top half and a bottom half output. But if I took the positive square root, it would just be that. And if I took the negative square root, it would be that lower half. So again, implicit is nice for certain things. So we'll get to this in a bit, because today I want to talk first about finding the equation of the tangent plane to either one of these. We're going to talk about how to do both of them, but we're going to rigorously work through the explicit version. Find the equation of the tangent plane to z equals f of xy at a point x naught, y naught. So this is like finding tangent lines, the classic Calc 1 problem. It's pretty fun too. We're gonna do some cool geometry. So I gotta get a surface. I need me a surface. Ooh, that tea's good. If you ever wanna come by for tea, come by for tea sometime. I'm always there. Evan's come by for tea. Get some good tea. We talked about stuff only Evan will talk with me about. It's great. So let's say I have a surface. So I'm going to make a surface. Well, let me see. I had a cool one drawn out, but okay, yeah. So that's going to be a surface. You're miling, you whatever. Just draw some wiggly ass rectangle, right? And you can convince yourself that it's a 3D shape here by kind of drawing some shading lines in there. There's a little bit of shading, there and there, just some stuff. But what's really going to make it look 3D is axes. And then I like doing the little, it's cutting through, kind of dented it in on the way in. And then imagine the vertex or the origins back there. I always like doing these orthographic things. I've always loved drawing 3D stuff. So, ooh, that looks pretty good.
It's pretty smooth.
Thank you. Thanks. Only took 58 years. Not that good at it. I guess I wasn't doing them right out of the womb, but pretty close after. So what I want to do is I want to take some point in the XY plane. So underneath here, so this is right, there's hidden lines there. And then there's going to be this is x-axis, y-axis, this is going to be x naught. And I'm making them light on purpose. This is y naught. So that comes out. That's x naught, y naught. I'm making it light because it's below there. And then straight up to there on this plane. So now that point right there is x naught, y naught, comma, f at x naught, y naught. So I plug that in and get that z point right there. Come back and see what that looks like. Yeah? You picturing this? Is this working? Yeah. Ooh, that does look good. Damn. So, new colors. Dark blue. So what we want to do is find the plane that touches in exactly one point, that it's kind of balanced on that point. Think about what a tangent plane would be. Take all the possible planes that you can intersect with this, and there's only going to be exactly one that perfectly just touches at exactly one point. If it touches at more than one point, which it could, you might have something like this. So imagine I had something that was like a cylinder, and I said, let's find the tangent plane right there. You could imagine that the tangent plane touches all along that line there. Can you picture that? Yeah, so picture a little soda can and just like a piece of card, like a playing card bouncing on the edge of a soda can. It's gonna touch in all those points. Here I'm just thinking about one particular point. So if we were doing it like this, the tangent plane at each of these points would probably be the same plane. all the way along there. And it'll all come out in the wash once we do the calculations. Same thing could happen this way. You know, I could have a soda can coming out of the board. Or I could have something terrible that isn't differentiable at all, like a sheet that looks like this, and it's got what's called a cusp on it. So it's a folded piece of paper. How many tangent planes are on that ridge? Right up here. Infinitely many. Do you see that? It's like this. Oh wait, that's Eric's. He won't mind if I bend it. Thanks, Eric. Appreciate you. So if I had something that's a little sharp, in other words, not differentiable, then the tangent plane is infinitely many, right? There's infinitely many planes that could touch there along that line and still just touch at one point. And even worse would be something that was like it had a little super point. So imagine like a needle-nosed kind of thing like that. Then there's, how many planes can you balance on top? Lots, exactly 1 point. So these are not differentiable here. We want smooth. Just like in Calc 1, when you can't find the equation of the tangent line to a point like that because there's infinitely many tangent lines there, same thing here. We're gonna assume smooth, where there's exactly one tangent. So, how are we gonna do this? We're basically gonna do Calc 1 in the X direction and then in the Y direction. Thinking about slices. So the slices that we did on skill check 4, which was like skill check 1. I got this stuff from Cybert. I was asked about this the other day. Like, why are these numbers all fucked up? I don't know, ask Cybert. He gave me the stuff and I just copied it like a monkey. And get a different colored pen. Sorry.
Pretty sure I got one around.
There's a nice blue. Okay. Oh, I think this is. Oh no. It's different, isn't it? All right. So, how are we going to do this? Well, first thing is I'm going to take the slice through x naught, y naught, z naught that is parallel to the yz plane. So imagine you took this YZ plane and you just cut this shape just like that. So it might look something like this. Let me see. Like that. So that what I've done there is I've taken a plane that's parallel to the YZ plane and just cut this slice right here. So this is the trace in the Y direction through x naught, y naught, f at x naught, y naught. So this thing is actually now what I've got. If I just focus on that line, this trace right here. If I just focus on that, I have a Calc 1 problem if I just want to find the equation of the tangent line here. So think about this curve and finding the equation of the tangent line right there. That's going to be part of the plane. So what we're going to do is we're going to figure out a tangent vector to this curve, and that's going to be one of our vectors. So let's call that V1. So what's our plan? Step 1, find the tangent vector, find a tangent vector to the to the trace in the y direction through our point. I'm sick of writing out the point coordinates. I'll just call that our point. Two, find, and let's call it, sorry, insert here V, let's call that V1. Find, step 2 is find a tangent vector V2 to the trace in the x direction through our point. So that means what I'm gonna do is I'm gonna come over here and I'm going to cut this thing parallel to the XZ plane through our point. And that looked like this color here. So I'm gonna slice it like this and just look at that trace that's there. So I'm cutting it right through that point, parallel. Do you see what I'm saying? And if not, let me know. Happy to like do other illustrations. Cutting right down that way, and unfortunately, it kind of, I don't like that syncing up with that. You're done now. So that's sliced, so I'm going to get a second tangent vector V1, or V2. So that's V2, and that's V1 right there. Then I want to construct the plane that contains those 2 points that goes through our point. Or excuse me, that contains these 2 vectors that goes through our point. So step 3 is find the equation of the plane, and we've done this already. So we're going to really pull in a lot of the stuff that we've learned over the last 7 weeks, 6 weeks, or whatever. Find the equation of the plane containing V1 and V2 as direction vectors inside the plane through our point. So do you see what I mean? I'm going to have, let's draw a little picture here now. So I'm going to have a plane that kind of looks like this. This is going to be my point. I'm going to have V1 like that. I'm going to have V2 in the plane, and this is going to be x naught, y naught, f x naught, y naught. How do I build the equation of a plane? Do you remember? Take a minute. Just take a minute and think about it. See what you can pull back up, dredge from our memory. If I've given you this information, so we've got our point, let's call our point x naught, y naught, z naught, just for the ease of notation. Take a minute. Let me drink tea. And we'll here, I'll give you a little bit of a hint. We're going to take an arbitrary point in the plane x, y, z. So we need that. We need our point. We're going to relabel c naught. I want to find all x, y, z points that live in the plane defined by these vectors. Do you think you got it, Camille? You think?
Take the cross product of the 2 vectors.
Indeed I do, ma'am. And what do I get when I do that?
You get the direction.
The normal vector.
Oh, yeah.
Yeah, that's good though, that's great. So what we're gonna do is we're going to take, so step 4 is get the normal vector, get a normal vector, n to our plane. And to do that, just like Camila said, we're gonna take n is equal to v1 cross v2, doesn't matter what order we do this in. One gets the normal vector pointing out this. If I want the normal vector to point out toward us, which way do I cross them? Yeah, if I want it to be like this.
V cross, or V2 cross V1.
So that, I guess it depends on how you're looking at this, but that would kind of go like this, right? Thinking right-hand rule. Does that make sense? So I'm thinking V1 cross V2. So using the right-hand rule, does that make sense? Yeah, that's all good. Appreciate you just going for it, man. So this would, if I do it in this order, by the right-hand rule, you curl your fingers in the vector cross product order, your thumb points the direction. But to be honest, that picture is pretty ambiguous. So let's do that. Let's actually figure out what V1 and V2 look like though. We don't have a form for them, I'm just saying V1 and V2. So let's get the form for them. So what is the slope? Let's go to this V1 vector. So here, let's, when you're gonna get the form for V1. So I'm gonna draw the picture here. I've got that curve right here that represents V1. And then I've got this point and that slope. How do I get the slope of that point? How do you think? What would you do? How do you get the slope of a tangent? Derivative. So I see the word derivative being mouthed. I need the derivative. I need the derivative in the y direction. So what I'm going to do, bless you or something, I'm going to take the derivative in the y direction to get the slope of this line. So if this is V1, remember this was in the y direction. So its slope is the partial derivative with respect to y, the rate of change in the y direction at x naught, y naught, z naught. And z naught just represents the point right there. So we'll say m equals that. So let's look at side view. Side view. So that curve kind of looks like this from the side. Here's our point. And then here's our tangent line. So what does slope mean? What does slope represent?
Rate of change.
Rate of change, so rise over run, right? So this is equal to the rise over the run, but I could think of the rise as m and the run as 1. So that if I move over 1 unit, I go up m units or down m units if it's positive or negative. So from the side view, the slope of this thing right here, I'm going to draw a little perpendicular. Sorry, I'll get out of your way, friends on the east end. And then that's going to be m right there. And m is this derivative value. So next, I got to turn that into a vector. What is the x component of this vector? So we got v1. What's its x component? How much change on v1 is in the x direction? Just 1. Not 1, because is it moving out of the YZ plane? No, 0. It's 0. This thing isn't moving out of the plane, so the change in the x direction is 0. Its slope in the x direction is 0. So this v1 is going to equal, what we can move faster on the next one, 0 in the x direction, because it's in a plane parallel to the YZ plane. Because I took like the YZ plane, moved it over and sliced. So it's not moving left or right out of that plane. So this is the x change. This is the x change. Comma, now the y change is just 1, absolutely. And then the z change is that slope, m. And m is equal to the partial derivative at that point. Get rid of this, so we'll come back to that. Then v2. Can you just take a minute and maybe guess what v2 is? Take a moment, don't say it out loud. Using this kind of reasoning, what do you think v2 is going to be? Remember, I'll give you some hints here. This is in a plane parallel to the xz plane. go through this whole thing here with some different, couple things labeled differently. That's a really nice surface there, Evan. That looks awesome. Yep. Yes, sir. Not yet, because eventually we would, but we're doing the explicit form. I've got z equals f of x, y. Does that make
Same
sense?
thing, yeah. X and Y.
That actually is your z naught, or no, it's not, but yes, that's it. Good question, really good question. Yep. What's your m though?
Partial X.
Yeah.
Did we define at any point, fx or fy, x0, y0?
Can, wait, say that, start that question over again?
Yeah, like as a function, we never defined it as a function, right? The ones that we're taking a derivative of?
That's this guy here. So maybe so it's this
Oh.
right-hand side here?
Right.
Does that make sense?
Yeah, yeah.
Is that, and that's what, okay, that is what you're asking. Okay, cool. So here, the change, the 1 unit step is in the x direction. So parallel to this, so it's like a 1 unit change. It looks bad here. You're gonna have to kind of make it out this way. But I'm moving 1 unit in the x direction, and my drop is the value of the partial with respect to x in that direction. So in other words, this is gonna be 1, there's no change in the y direction, partial with respect to x at x naught. So those are our 2 vectors. Now, I'm going to take the cross product. So n is equal to v1 cross v2. Let's write that out, because we now we have a form for it. Let's get new colors too. And I'm going to use ijk across that top row. I saw a lot of people not putting ijk in here. Just please do that. I mean, you save a very minimal amount of time. We're not in that big a hurry. Look, I'm taking so long just talking about it, like 10 times longer than it'll ever take you to write them. So put them in there to be safe. Because a lot of people who didn't do that got the signs wrong then on the output. So now I'm gonna put V1. I'm gonna put V2. Yep. And I'm gonna crank out my cross product. I also recommend doing this cross product bit by bit with the expansion by minors thing. So in other words, I times the subdeterminant that's left. Minus j times the subdeterminant that's left when I remove that column and that row. So 0, 1. Again, fy, fx, and we're almost done. And then plus k, this little subdeterminant. Now we crank that sucker. Is questions? Are we good? Good to go. Okay. So now we crank that up. Now I'm going to do this rule that this determinant is that product AD minus that product BC. Yay, that product is 0. That product is just, so I've got I times F partial with respect to X. Minus, I'm gonna put a little parentheses because I got a minus there. I'm gonna keep the sign straight. A times D is 0. The B times C gets negated. So it's negative Fy, X naught Y naught. Oh, and I forgot my J. Didn't I even copy my J? Everything cool? Can I help with anything? It's cool if you're talking about it, cause I hear you talking about this.
Yeah, I was just wondering the order of the crossing part.
Yeah.
Like, is it top left?
Is it AD or BC? It doesn't matter as long as the.
It doesn't, it's definitely got, this is your positive product, as long as it's down and to the right. And kind of just think like what the real numbers are, you've got the positive numbers on the right, negative on the left. That's how I kind of remember it. So the product down to the left gets negated, product down to the right stays positive.
Right.
Does that make sense? Yeah. Cool. And then plus K, -1. Because AD is 0, BC is 1, but I tack a -1. So now I can write out this, these minuses cancel. Check out what our normal vector looks like. And this is actually very informative. Partial with respect to x, partial with respect to y, because I got 2 negatives, comma -1. So that's your normal vector. Let me stop for a second. Let you get caught up. Let's clean up the board. Because we're almost home now. Once we have the normal vector, we're gonna go use the normal equation form. So let me regale your memory with that. So, normal form of a plane. So with normal vector, this pen is dying. With normal vector, n equals, let's just say it's ABC, through point x naught, y naught, z naught. So that equation looks like this. It's basically, let me also, because it's so much easier if you understand what we're doing. We're taking our plane, we've got the point we want on it. We pick a point we want to describe in it. We create a vector, that minus that. So I take the arbitrary xyz minus the point I know. That vector is in the plane if I shift it to the right spot. And I want that dotted with the normal vector to be what? 0. And now you don't have to remember anything, because you can build it. Just thinking about those relationships. Every vector in the plane is orthogonal to the normal vector n. So, can I explain that? Is that okay? I mean, I just people deeply thinking. I'm going to stop and let them deeply think.
So that's the same thing we just did?
That is, this is what we're going to use, Czar. We're about to plug the stuff we have now into that. So what we've just did, was we computed the n, the normal vector ABC. And so now we're going to plug the stuff that we know into this equation to get the equation of our plane. So for us,
Oh, this solves the equation for the plane?
what is that? I'm sorry, what's the question, sir?
No, I just said, oh, this solves the equation for
Yes,
the
exactly. For us, this is going to be, actually, let's just write out what this means so you can remember the other form. A times that plus B times that, y minus y naught, dot product, plus C times z minus z naught equals 0. A, B, and C are your normal vector components. So for us, the tangent plane has formed, this is going to be pretty, partial with respect to x at the point x naught, y naught, times x minus x naught, plus partial with respect to y at the point times y minus y naught. Plus, now this part gets really nice and simple. C, what is our C? It's minus 1 times z minus z naught. And that equals 0. let's rewrite this, because this can be made super, super duper pretty. That's fine, we actually have our whole equation right there. We don't need to do anything else. But we can, and we will, because this will also give us something we need in a minute. But let me stop it and make sure there's no questions on that, because this is what I would remember. So this you should have written down. That's the equation of the tangent plane through x naught, y naught, f of x naught, y naught. So notice I got this -1 here. So I'm going to, just to like, because I'm sick of writing them, I'm going to suppress this x naught, y naught. And so rewriting as partial with respect to x times x minus x naught plus partial with respect to y. And these are evaluated at the point. These are constants. And y minus y naught equals z minus z naught. Just shifting because this is negative. So I just add it to the other side. But then I'm going to do one more thing, and I'm going to add the z naught to the other side. So I've got z, check it out, z equals the z coordinate, partial, this is, remember these are constants, because I feel weirdness coming. These are constant expressions, constants, not expressions. But now you've got a nice z equals form for it. Shit, I'm just gonna let the whole thing out. So z equals f at x naught, y naught. That's the z naught plus partial with respect to x at x naught, y naught, x minus x naught plus partial with respect to y at x naught, y naught. And then we'll do an example here in a minute. That's just a lot of abstraction. Here's your equation. So let's do an example. Find the equation of the tangent plane to z equals x squared minus y squared at, let's pick something cool. So let's say 2, 1, 3. Because when x is 2, that's 4, minus 1 squared is 3, so that point is on that surface. So let me let you kind of go with this. This is your f of x, y. Step 1 is find the partial derivatives. Not too bad. Step 2 is evaluate them at 2, 1. I'll write up here the steps, and you can look up and make sure you're proceeding sanely. Step 3 is not needed here, but it might be. Use that form over there. You good, Kayla? I was just okay. I was just like studying your studying of it. Yes, sir.
When I express my partials with x,
So no. So now first, yeah. So first, just do it like that. So just without the x naught, y naught. So what's that gonna be? What are we gonna get? We take partial now with respect to x.
Oh, so you want me to do that?
Yeah, let's do it. So write f
Oh.
of x of xy. Yeah. Not yet, not yet. So we're gonna use them as variables. So what's the derivative of this side with respect to x? Yep. So yeah, but does what is the y squared is a constant? Yeah, there you go. So 2x. There you go. Now what about, let's write out partial with respect to y. Yep, solid. Now I'm gonna plug in the x and y coordinates. So x is 2, y is 1. So now I can evaluate them at 2, 1. Does that make sense?
Yeah.
Go for it. Yeah. Oh, wait, how'd you get 3? I'm sorry, how'd you get 3? Oh, okay, so here we just need the x and y coordinates. So this is your x naught, this is your y naught. You don't actually use the z naught here yet. So, sorry, I'm erasing for it. But let's go ahead and write out what you want. So at 2, 1, and then you want y at 2, 1. That's what you want. Does that make sense?
Yeah.
So what are those gonna be? There you go, awesome. Solid. Then just plug those into that formula. And you pretty much, and this guy right here, these 3, that's the f at x naught, y naught. So this thing
Oh,
right here,
right,
you
right,
see?
yeah.
Yeah. So you get it, so
Right
it's.
now.
Does that make sense?
Yeah.
There you go. And just plug and chug. Not much chugging. You keep pondering, you got a question?
No.
You good? Okay. He was good coming up. Okay, I think so too. See it. Evan, how you doing, friend? Can we help with anything? Cool. So this 2 is your x naught, 1 is your y naught, and so your partial with respect to x. So your f of xy is x squared minus y squared.
Yeah.
Okay, you good with that? Your partial with respect to x, what's the derivative of that with respect to x? Yes, sir. And, but the y goes to 0, because it's constant. Does that make sense? So let's do this. Okay, this. We need to probably talk about all this. It's fairly new. What about this one? What's the partial? If I treat x as a constant, what's the derivative? There you go. So a little bit of sanity checking up here on these things. And then your point is, so your x naught is 2, your y naught is 1, and your f at x naught, y naught is given as 3. I gave that to you, but literally I just plugged 2 in here and 1 in there and got the 4 squared, 4 minus 1. So when you evaluate these, and I highly recommend writing these out. That's why I kind of wrote this like this. So find these guys. We just did that. Step 2, evaluate them at the point. So now, so this is step 1. Step 2 is fx at 2, 1, and fy at 2, 1. So this is just 2x, 2 times 2, 4. This is negative 2y, so negative 2 times 1, bless you. Negative 2. So let me know how that feels. If it needs anything, happy to help. You good, Daniel?
Yeah.
It's okay.
It's
It's okay. It's okay. As long as you're not going to a dark place.
no.
No, okay, good. It was kind of a look I've never seen from you before. So
Really?
you were pretty far away, I think.
I'm tired.
It's all right.
I'm better since I know.
It looked like you might have been like on the plains chasing an antelope or something, like kind of like.
Got the sheep jumping over the fence.
Kind of something was going on there. You were reverting to primal Daniel. So now just plug this stuff into that star formula. You're pretty much done. So the equation of the plane is z equals the value of the function, which is 3, plus 4 times x minus the x coordinate, plus y, or negative 2 times y minus the y coordinate. And I would just leave it like that. You can go crazy and simplify if you wanted. Some people just like that stuff, so distribute the product, bring the constants together. And if you did, and I might be one of those people. So it's going to be 4x minus 2y, and then that's minus 3. So this is also a beautiful answer. Good. It's definitely time for spring break. I'm feeling it in the air. I'm just seeing.
I got a question.
Yes, sir.
So for that general equation, the 3 plus 4x,
Yeah.
for the 3, so for the z component for z naught, you can just put that in as that if it's a 2, or how come there's no z minus z naught? I guess that's my question.
Oh, so this is the z minus z naught.
Oh, okay. So
We had brought it over because, I don't know if you remember in the derivation, there was that -1 as the third component of the normal vector.
yeah.
And that allowed us to bring us over. You might have been out on the plains,
Yeah.
possibly during that part.
I think I wrote it down.
I think so too. But this is my Z naught right here. Cool. Let's do one more practice. And actually, let me just give you the form for the implicit. You're gonna like this. This is lovely. I'm just gonna give you this. Honestly, we don't quite have the machinery yet to make sense of it otherwise, besides just being given it, but we will. So if we have an implicit surface, implicitly defined surface, f of x, y, z equals 0, or frankly, there could be a constant over there. It doesn't really matter because we're gonna take a derivative anyway. The constant will go to 0. And x naught, y naught, z naught is where we want the tangent plane. To touch the surface. Lots of words I'm not writing up there. The equation is, so you've got this big function, capital F. We're gonna take its partial with respect to x. But here we actually probably will have to plug in 3 points. Well, that'll be our next example. Times x minus x naught, plus partial with respect to y. At the point of tangency, y minus y naught, plus partial with respect to z now, at x naught, y naught, z naught, times z minus z naught. There's your z minus z naught, Daniel. It's hidden there. This becomes exactly the thing that we have, our exact form that we had. I'll just for those who want a just full complete view of this. When we had this, z equals f of x, y, I could actually write that like this. And this would become the capital F of x, y, z over there. And notice that the partial of this with respect to x is just the partial of little f with respect to x. Partial of this with respect to y is just f little f with respect to y. And what's the partial with respect to z of that expression? -1, because this is constant with respect to z, and then just goes that. And that's that -1 that we had before. And you would be putting it in here, and then it would become exactly like our other form. If that makes you feel better. If that makes you feel worse, don't think about it. It's all good. Let's do this one. So let's find the equation of the tangent plane to x squared plus y squared plus z squared, and we're gonna rig this. Here's how you rig a problem. I wanna make a sphere, and I'm gonna figure out the radius after I figure the point. So let's do a point. Somebody give me an x, y, z point, but don't be too evil. What's the x? Give me one. 7. 6. No, we're going for 7. Somebody else give me a 1. No, let's get. Somebody give me a what?
13.
Oh, mother. All right. Oh, no. Oh, no. You're going to do the math. That's fine.
Please, 1.
23.
19.
Can
we do all prime numbers?
LeBron.
23?
Alright.
Here's your hero. So, I want this to equal some number over here. How do I find that number? I want this point to be on this sphere.
Square all of those.
Take that squared plus that squared plus that squared, and it has to satisfy this equation. So luckily, this is 169 plus 49. 169 and 49. I can't do that in my head. 218? 218. So it's a sphere of radius square root of 218. Whatever that is. So, what I would love for you to do for me, please, is that. Find those partials. These are straight, right? This is your f of x, y, z right here. It doesn't matter if you move the 218 over or not. This says, please erase the whiteboards after each class, and someone said, please make the whiteboards erasable.
Wonder how old that piece of paper is.
Pretty old, probably.
It's probably been out there for a long time.
Yeah, it's pretty grubby.
Yeah, carbon dated.
26y and 14 times 7 is 98 and 336.
Made life good, right? Oh, what were those points? Jeez. It's not so bad. We can multiply by 2 pretty easily, so. Oh, and true. Oh, this will be cool. This will be actually a pretty interesting discussion. So, a hero in one sense, but a troublemaker in another. But a good trouble. Good trouble. The kind of trouble I like. Oh, wait, no. Yeah, because 0, right? So it is 0. So it's okay. And 0 minus 0 equals 0. So I'm gonna multiply it all out just a little bit. So, oh my goodness. What is that, 98? That's not too bad, right? 98, 7 times 14? Yeah. Oh, man. 169 times 2 is 338. Somebody check this, is that 338?
Yeah, it is.
Yeah. Thank you. 338 plus nothing equals 0. Oh wait, dude. Plus 26y minus 338 equals 0. Sorry, I was doing bad, not writing the math I was thinking. And so, we got 14x, I'm just gonna do one more, plus 26y,
You want us to say it, or?
and just tell me what it is.
436.
Thank you. Cool. Where's the z? What's happening?
There is no C.
Yeah, there is no z. That's a good answer. That's a really good answer. Why? What do we have here? We have a sphere.
It's just.
Is it
And
like
where's our
intersecting
point of
the origin?
tangency? Yeah, so we're, so let's see here, so there's, we'll fix him up here. Like popping up like that, right? And then there's, so this is x, y, z. So where is our point? It's 7 on the x-axis, 13 on the y-axis. So it's a little further out this way, but there's no z. So this is 7, 13, 0 right there. What would be the tangent plane there on the side of a sphere? Does somebody have a ball? Does anybody have a ball? I don't even have an orange. I had one this morning. I got that shitty candy y'all hate, but it's too tiny. It's somewhat ovular. What does the tangent plane look like at the top of the sphere?
Horizontal.
Horizontal, perfectly horizontal. Does the z change on that? The z doesn't change on the tangent plane at the top. What doesn't change on the tangent planes that are around the equator? Or z is free, right? Z can be anything. So, sorry, yeah, I was asking that question asked backwards. At the top, the equation of the tangent plane is just going to be z equals something, and the x and y will be free. Does that make sense? At the top, you'll have the z coordinate, and then that's where the North Pole is, whatever z is, and we could figure that out. I guess it's the square root of 2, whatever that number is over there. And on the side here, what we've got is a plane that just touches the sphere in exactly one spot, and the z coordinate can be anything. That's why it's not mentioned. The z is free here. So let's just make a little note that z is a free variable. And you want Z to be able to equal everything, because otherwise you wouldn't get any movement up or down. You just have the tangent line right across there. Seems like enough. Seems like enough. I kind of want to talk more about one application of this, but I don't want to do it today. And you're probably fine with that. Yeah, you seem fine with that? Alright, good. Take your silence as acquiescence. Okay, so today or tomorrow, anyone who's making up skill checks this week is going to send me a list of the skill checks you're making up with, and it might not be all the parts. You don't always have to make up all the parts, right? One part might be, say, not yet. You're gonna send me the things you have to make up. You're gonna send me 3 times that you have on Wednesday, Thursday, and Friday.
Is this for only retaking though?
This is only for retakes.
Okay.
Yes, if you have a 5 or more, you're gonna submit a correction and turn it in the right way by Wednesday. Does this sound good? Okay, your fate is in your hands. Thank you. You.
I don't know if it's,
Yeah, that's good.
It's drowsy, so.
Yes, sir. What do we got?
So some correction.
Yeah.
Where's your correction?
Oh, I'm sorry.
I erased it, but it's.
So don't do that in the future.
Oh, okay.
Do not do that in the future. I want to see what you did wrong